All right, guys, I'm going to go ahead and explain this Kamikaze Ken lab so that you guys have an idea of what's going on. First thing is obviously these are fake numbers. So the averages that you see are just purely fake, made up, but I'm using this as an example. You're going to do multiple trials, but you just take your average, and the average is the only thing that we plot. So the points that I've plotted over here in my graph are the averages that I got. Now, next up is make sure that you're reading all of this. And if from the previous page, it tells you what you're supposed to do. Obviously, I have not labeled and don't have a graph title, but that's for you guys to do. And do not follow these scale. Uh, Definitely not for the y-axis because yours could vary. These are just based on what I did. Now, for everyone's class, I try to get everyone to have the same x-axis as far as the scaling went. So everyone should look like this for the X, but your Y could be completely different. Now, again, these points, the solid dot ones, are the averages from here. And when you do the best fit line, remember that you don't use those points. Instead, you use your points from the line. So the points that I was going to use are ones that I could read easily. And if you notice, these are the ones that I'm going to be using right here. So this one and this one, do your little dotted lines. And if you notice, this is like a 0.5 and a 6.5, which is definitely, we're not using half rubber bands, but I'm using this as an illustration and an example so that you're aware that it's the purely off of my line, not from the data points. Do not do that. So you're going to use your own points to find slope. When you go to the next page, go ahead and look at the next page. It's probably for best that you do the actual slope first. So find the slope first and then come back to this. Now, this one says, what's the y-intercept? And it actually wants to show you, for you to actually show your work. You can eyeball it, but that's not showing your work. So let's go ahead and show you how to do it. You still use the y equals mx plus b equation, but the way you solve for b by showing work and find the exact value is that you use one of your points, one of those points that you selected, and you plug that in for y and x. You also have found m at this point. So you have y, you have x, you have m. The only thing that's missing is the b value, the b variable. So you can rearrange for that b and solve for that and get your exact answer that you need for this right here. So answer goes here, and then make sure to talk about what you believe that represents. I already covered that in class. Now, what I mean by use one of your points, again, that's from the points that you selected, these open ones. So I could either use the 6.5 and the 1.5 to plug in for my x and y, or I could use this 0.5 and 0.4 and plug in for my x and y. Do not use those numbers. These are purely hypothetical. I'm just making an example. Yours is going to vary, but it's whatever you selected for your slope that you base off of. You use one of those points, whichever one, doesn't matter. So again, it's best for you to find the slope first, then come back and do this. The linear regression equation, that's read step 4 if you need a reminder of what that equation is, and you can go ahead and solve for that. Now, I will provide you guys with what the ultimate jump height is. It will be either up on the board or the substitute will let you know, and you can go ahead and solve for how many rubber bands you would need. When you get to the conclusion questions, this one is pretty much just like this right here, and think of this as being the new ultimate jump height. So there's a specific one that I'm going to give you, and everyone's going to have the same one here with this 100 meters. And you're going to solve it the same way that you solve for this. You're solving to find how many rubber bands that you need. Now, as far as the question for rubber bands goes, let's just say that theoretically, what if you get an odd decimal? You get like something, let's just say that you put out your answer as 57.7 rubber bands. Okay, remember this is for a safety issue, so you never want to round up on this rubber band. It's better to go lower and play on the safe side so that they don't stretch out too far. So in this case, you would put 57 rubber bands. If you, for this 100-meter ones, let's just say hypothetically, there's going to be like, 103.2 103.2, or even if it's 103.7 rubber bands, doesn't matter. We're not applying the rule of rounding. We're going to go on the safe side and always round down. So we get a whole number of rubber bands, and it should always be 103 rubber bands. So these were hypothetical numbers. And these are purely conceptual questions. So I hope this answers everything that you need and that you guys are able to do this. Remember to go ahead and scan both pages 13 and 14. Either take pictures of them or take a nice PDF scan of it using your phone and submit it on Canvas. And you should have submitted the notes from page 27 and 28 as well. All right, I hope you guys have a wonderful day and take care.